I feel like you guys were really tired and didn't really have many questions for me. So yeah, ask me anything. So if you want to know anything about me, like where I went to school, what sports I played, what I mean, if it's school appropriate. Can't have conversations that are inappropriate. But yeah. I don't want to share their name because I tell my classes and that would be rude. But the worst teacher that I had was one who had their own coffee maker in their room and would normally like write something on the board, and it would be like somebody was talking about the other day, like open your book to whatever, read from here to there, and then do this worksheet, and then she'd like go make a pot of coffee, and she wasn't like involved with us. And then like 15 minutes later, she might be like, "So, are these questions? Why aren't these questions answered?" Like, yeah. So that passive kind of teaching was not my thing. Yeah.
What's the most embarrassing story?
Somebody asked me that yesterday, and I think probably the fact that I can't grow a beard because I burned my face with a potato cannon, but while that's also embarrassing, my potato cannon was pretty sweet. So if you want to hear that whole story, talk to me later, but that's I can't grow a beard, so that's just sad, because I would like to have an option. But burn my face, not good. Careful with fire, kids. A couple of you are looking at me like, I can't tell if you're lying or I tell you guys the truth. Yeah.
First date.
First date, Casey Conrad. Did not marry her. I was in 7th grade. Then, yeah, something like that. It was like a forced thing. Like our friends like made us. They're like, neither of you have been on a date ever. Then my first kiss was very heavily persuaded on the Ferris wheel because it was so romantic and we had to do it and I was going to miss my moments. And it was not what I wanted it to be because it was like peer pressure. So don't give in to peer pressure. But it was, it was on the Ferris wheel. It was a good moment.
Dream car.
Dream car. I don't know. I like to drive off-road and stuff. I'm not even driving my car today because my buddy's borrowing mine to go on a camping trip this weekend. I drive a RAV4, like an SUV, because I kayak, I cycle, I do whatever. So it's got to be able to fit a bunch of stuff in it and all my dogs. Honestly, I'd really like to put a 4Runner because the back window rolls down. I love that feature that the back windshield drops down and you can like the wind just like flows through your car. We'll maybe take like 2 more. Yeah.
What's the worst thing you've ever said?
Worst thing I've ever what? I probably can't say that in school.
That's bad. And second.
On. No. Sorry. I was trying to think if I've even killed an animal. I've eaten frogs, like frog legs. I've eaten a rabbit, pretty good. Squirrel, okay. Squirrel's not that great. I've eaten venison, which is deer, but I didn't kill it. Yeah, I'm from Coshocton, rural, like country town. We graduate 100 people a year. 100. Worthington has 2 high schools who each graduate hundreds of people each year. So the district together graduates like upwards of 1,000. So Worthington's approximately 8 to 10 times the size, population-wise at least, of where I grew up. So a very small town, people have lots of hobbies. The first day of hunting season, we don't have school because people don't show up. So they just decided to call off school for the first day of hunting season. So that's a little bit about me. We can play more of that as the year goes through. But yeah, 4 minutes. So we're right on schedule with things. So the first thing we have today is just a 2-minute video from YouTube. So yeah, super cheesy, corny, but bear with it. It does have some really good information to get across. So you guys know, as we go through the year, I want to make sure that you are familiar with where things are in the class. Obviously, lots of resources here. You can see what they are, calculators, pencils. Colored pencils are organized over here, or there's just kind of like a disorganized cup here. If you get them from here, put them back to there. Don't get them from there and then shove them in the cup, because these are like ones that don't match those colors. Paper, scrap paper, like blank, is right here. One side has stuff printed on it that is unnecessary. When I get copies, that happens. Graph paper, right here. There's normally a stack of like random paper types right there by the calculators. And then if we're doing quadrant graphing, these are single quadrant printed graphs. think that's pretty much it. Dry erase boards, when we start to work with them, are on both sides of this thing. And then other stuff that as we work with it, or as we need it, then you'll work with it. If you are sitting right in this area, I may ask if somebody will pop up and turn on the sound. This is an amplifier that controls my speakers. This big button with the red light above it, that's the power button. If the red light's on, it means off. So when you turn it on, the red light turns off, the screen turns on. So if you're over here and I ask, like, oh, you turn the sound on, that's what it means, because if you're really quiet, you can hear electricity right now. When you have an amplification system turned on, especially if it runs a far distance, you can hear the electricity. It drives me crazy. So I turn that off when I'm not using it. All right, you QBs. Remember, this is all real data.
This is really hard, but I believe I can finish it. I'm going to keep trying different things.
Think about which student you would be.
That's exciting. What's happening right here? They're trying to work on a problem. Right? It's so exciting. Hey, what are you doing here? Watching your super awesome brain grow right here, right now. Really? Yeah. You believe in yourself and you're working on a really challenging problem. What does that mean? Well, you're also working on a challenging problem, but for some reason you don't believe in yourself. And that means that your brain won't grow as much. What? You totally have the potential in yourself. As long as you start believing in yourself, your brain will grow a lot more. Wow, I can do this. I really believe in myself now. Do you remember in the last film we showed you that when you make a mistake, your brain grows? Well, scientists actually found this. These are heat maps of brains of people making mistakes. And these brains are the people who have a growth mindset. They believe that they can learn anything. And their brains were on fire with brain growth when they made a mistake. But the people who had a fixed mindset, who thought their intelligence was limited, their brains didn't spark and fire with growth as much.
So guys, this is real data. I go down to OSU once a year and check out stuff with my heart and get put in an MRI and stuff. This goes from 150 to 550 milliseconds. So this is like a blip picture of somebody's brain working. This shows you the amount of blood flow not happening. This shows you an intense amount of blood flow happening. Brain growth, brain activity. So we're not making this stuff up when we talk to you guys about your attitude matters, your mindset matters, believing in yourself that you can grow. This stuff really does matter.
And they made a mistake. And this is really important for all of us, teachers, students, everybody. If you go into a hard situation believing in yourself, thinking, I can do anything, and then you struggle or fail, your brain will grow more than if you go into that hard situation thinking, I can't do this. So it's really important always to believe in yourself. It's also really important to struggle and fail sometimes. Those are the best times for brain growth.
So we're going to keep this in mind as we go through today, because I have a hunch that we're probably going to struggle just a little bit. So you have in front of you the squares to stairs. And if you just want to look at the side that just has it once, there's a side that has it once and a side that has it a bunch of times. The one with a bunch of times is so you can look at it in different ways and use colors and color code it in different ways to help your brain. But here's the launch questions we're going to think about. First, you're going to think on your own and kind of have some time to color it if you want or whatever else. But the questions you want to think about: what do you notice about the pattern? What relationships do you see? How do you see it growing? Because we can tell it's growing, but how do you see it growing? Do you see it growing up? Do you see it growing out? Do you see it growing from the bottom? Could you use colors to represent and show this growth to help you visualize and understand what's happening? So take about 2 minutes. If you want to grab colored pencils, highlighters, any of that stuff, come up and do that. And then after a couple minutes, I'll tell you to go ahead and have that conversation with your group. I really suggest that you use colors. And then all come around and grab your note card or your playing cards while you're doing this. You guys only have 3 here? Or maybe yellow jacks? Aha. Alright, just grab them and get back to your seat. Do not spend a bunch of time deciding colors. Not that important. You guys only have 3. You guys only have 3. So for about another minute at least still, just think to yourself, kind of color on your own, think about what's changing, how much is it growing by, how could you describe this? And really then the questions that we're going to be looking at trying to answer are these. So if you want to glance back up here for just a second. What would, so once you make those connections and figure out that growth and everything, what would figure 10 look like? What would figure 55 look like? And if we had 190 squares, would we be able to perfectly make one of these figures? So I'm going to frame your thinking for a second. And a lot of times I will do this in some interesting ways. So let's say, or for those of you that don't know, I work at Rockwell. So on the side, I don't like to pay for things I can get for free. So to get a free gym membership, I work at Rockwell. So we have a bunch of milk crates. And it's like a workout thing. If you ever watch American Ninja Warrior or whatever, people have weird ways to work out these days. So sometimes we pull out the milk crates and we start making stairs. And if we get really ambitious, we'll zip tie them together and stuff. We'll make forts and whatever. We have a lot of milk crates. So imagine I stick down 1 milk crate, step up onto it. And then I stick down 2 milk crates, step up onto those. Stick down 3 stacked vertically, step up onto those. I'm making a staircase, right? I'm just climbing up the stairs. So once I get on top of 10 milk crates, how many crates did it take me to get there? If I'm standing on top of 55, how many did it take me to get there? So these are the things we want to think about. If in my closet I have 190 milk crates, can I make a perfect staircase? I didn't do this last year. No, last year. Oh. I think it's just because it's easy for them to say, I can't control that. Based off of all of them, I don't know. All right, talk with each other. Talk with your group, and you're going to have differing opinions. That doesn't make it right versus wrong. There are multiple ways to look at this. Talk with each other and try to start answering those questions. What about level 10? What about level 55?
I noticed that when the problem is that it's always the right triangle, and it's like counting. So if you go 2, there's always 2 up and 2 right, 2 up and 2 at the bottom, and then 3 there's 2 up, 2 up, 2 bottom, and 2 going back. And then add 2. So it's similar. like 5, or like another layer, which is completed 10, and then that's 55.
All right. So let's at least answer one question. Then I'll release you again to keep working. Who can talk to me about how you see the pattern growing? And do you want to bring your paper up, or what, like? So what do you think? How do you see it growing?
Every single time. So on the second block you add 2, third block you add 3, fourth block you add 4.
So you said at so let's be careful saying blocks. Let's say figure or stage or whatever. So you said like at figure 2 we added 2. So to get there, I'm going to color code some of this. You said boom boom, we added 2. And then sorry, keep going. What else did you say?
And then on the second one, well on the third one you add 3.
Okay.
Fourth you add 4.
So interesting. You keep saying the same number twice. For the fourth, you add 4. For the third, you add 3. That's interesting. So what would I be doing next then?
You add 5.
I'd be adding 5. So if we think about figure 10, how would we get to figure 10? Yeah. Yeah. Or, I mean, you can come right here if you want to show your paper. Like with the dot camera.
I noticed this, that like, figure 1 is 1 block. Figure 2 has 1, 2, 1, 2. Figure 3, 1, 2, 3, 1, 2, 3. Figure 4, 1, 2, 3, 4, 1, 2, 3, 4. So 10 is probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one was 55.
Okay, now the one thing I would be concerned about is, are you counting blocks or just saying how long it is? So you counted the same block twice. Do you know what I'm talking about? Mm-hmm. So I agree with what you're saying. Everything you said is absolutely true. But just be careful as we look at it. If I see 10 vertically, if I forget about the bottom block and can't count it over, and I just shift over, what would the next step stack to the right have? 9, then 8, then 7, then 6, and 10. But it's still pretty tough to think about adding up though, right? Because like stage 55. Think about this with your groups for a little bit longer. Talk with each other, see how could we figure out. So actually I'm going to introduce a tiny bit of notation before I let you guys go again. When we talk about the total number of squares, we're going to use what's called function notation. We're going to say the squares at stage 1, well, there's 1. The squares at stage 2, there are a total of 3. The squares at stage 3, there are a total of 6. So this is called function notation. This is the figure number. And if we write that in general form, we're going to use n to represent number. So we would say S sub n will have some rule, we hope. And we don't know what that rule is going to be. And the questions I'm asking you to solve, how many blocks would S sub 10 have? Or S of 10, the 10th stage? And how many blocks would stage 55 have? Chat with each other for another couple minutes. Please make sure you have your names on the paper that you have and the paper that you're getting. First and last name, and then letter group if you so choose. But please make sure your name is on there at least. So, we'll come back to the staircase. Keep that in the back of your brain for a minute. We'll come back to that. We're probably going to revisit this a few times through the year. Check out your Growing Squares extension page. So you have the original Growing Squares problem, but we're going to ignore that for right now. So I'm actually just going to fold this down for the time being, just so I can scooch. So look at this one. We had a staircase, and most of you were talking about the vertical and the horizontal. And then we had this chunk left in the middle. Well, if I take the chunk in the middle away, it's going to make this easier. Because I feel like a lot of you had ways to describe the vertical and the horizontals. So I want you to look at this. I guess we can call this, especially since we're learning the Greek letters, let's call this the beta set. We'll call the original staircase, we'll call this alpha. So that's our alpha set. Let's look at our beta set. So, same questions for your group. Just go straight into group discussion. How do you see it growing? How could we describe this? Think about pictures or words. And what about stage 10 and stage 55? How many total squares would you need for this? So talk with each other.
It's sort of open, so every time a new stage progresses, you have to add two to like the top and bottom. It's the top and then bottom. You mean one on top and one on bottom? Yeah. And then you just go on and on and on. Or you can put one in the center. So it'd be kind of easier to see how many blocks it was. Because like if it say it was 55, 55, you had 55 and then guy keep it.
So I can't give you a hint up there. Please move on from the stairs right now. I am strategically guiding you. Please be looking at the L's. I see some people still fighting with the stairs. That's good. I love your dedication. But move on to the L right now. So I kind of give you a hint up on the board. Think about total squares. So squares needed for stage 1, squares needed for stage 2, squares needed for stage 3. Talk about that change. What do you think, guys? What happens between stage 1 and stage 2? So that looks like the same as the original stage, right? But then as we go to stage 3, we can see it's not the same as the original square. So how do we go from stage 2 to stage 3? What do you think, Wyatt? How do we go from stage 2 to stage 3? Well, so how many blocks do we have in stage 2? Yeah, 2. So one way that I visualize this is I would say like, okay, if this is what I had, then I had this previously, the new are these. So if we added 2, well that was consistent. Does it stay consistent here, and can that help us do anything? No, that's S. That is squares at stage 2. So you guys remember, this is function notation. This is saying, and I should have explained this better, this is saying squares, squares at the number of the stage equals some quantity. So if I say S1, that is not multiplication, that's saying squares needed for stage 1 is 1. If I go in squares needed for stage 2, how many? 3. Squares needed for stage 3? 5. Squares needed for stage 4?
7.
So I try to start thinking about a rule and what's happening here. Actually, should have put this up to get you guys thinking about this. So think about that. Keep working as your group. Try to determine, could you write a rule for any stage using n, because we don't know what stage. It might be stage 10, it might be stage 55, it might be stage 8,742. We don't know what stage, so what do we call this n that we don't know? Yeah, a variable. So let's go ahead and on our paper jot down, especially if we did not remember that. This is our variable, and it's going to represent the stage number. All right, keep working. So how does adding 2 every time look then? If I just said, how many then are in stage 6?
Do like a draw or say the numbers?
Say
11.
11. All right, how about stage 8? How about stage 30?
Oh wait, so 30.
So add 2 every time. So can I pose a question? What are you actually doing? So I just heard you say we're going to start at stage 4. You're changing 1 from 1. Happens every time, right?
Wait,
so
wait.
you're going to
So
go
like,
stage
if you
5.
counted it up like this, like in multiplication, you do that, so that's
Thinking
4.
about every change.
If you did that, if you're at the bottom, it's say bottom's 30, the top is 30 as well. You gotta take 1 away because you already
What were you
counted
saying?
the quantity.
So in your head, are you doing 30 plus 30 or are you doing 30 times
30,
But to get to 55, how many
30
steps
plus
up do I need to go if I start on step 1?
30? What about stage 100?
I'm at 1. So to get to stage 2, how many changes were there? I added 2
So in your
twice.
head, are you doing
I changed
100
once. I
plus
changed 5 too. I
100
only changed 1.
minus 1? Or are you doing 100 plus 99?
How many changes?
What's going on in your head?
2 changes
I
to get to
think
stage
100
4.
was 100, and since we
So
already counted
to
the
get
bottom
to
one
stage
right there,
55,
they got minus that
how
way.
many changes will we have?
So, use of the pattern is
Walking away.
Wow.
which it is true. You're correct. It But
So we think you
now
can.
you're not. So you didn't actually do it right.
Well, gotta wake up. You want to do jumping jacks? You can wake up on your own, and we can all do jumping jacks.
Right.
Work on the push-ups. All right. So what do we notice? What do we see? What at least? So we got some totals written down. What do we see about our total blocks? We add 2 every time.
Do you remember
Every time the stage goes up, every time we step up. So if we jump all the way to
what? Multiplication is actually just numbers, but what?
Addition, subtraction, division.
no, really, not with this one.
No.
With this one, we
What
probably
is
would,
repeated?
which is what we know right now. They already said it's crucial.
So even though having add 2%, right? You got them label here.
So the
This
question
time,
is, get to stage
this first one
5,
added 2.
how many times
And the next
would you have added 2?
So you repeatedly adding 2. That's why multiplication ends up being
Play it out.
because you're just
See
adding over
at
and
stage
over.
4, how many times did you add this? Because we're starting at stage 1.
So do you think you could tell me how many blocks would be in stage 11?
Does that stay true to the other ones? You have to look for every stage that you see and the stages that you can predict.
One.
So drawing on, and what was the other part of the question? You picking up?
I'm kind of lost.
Overall set on what you said. You know how many? Not writing it down.
What do you mean 6? Well, what do you mean by why are you multiplying by 9?
Get there. But you understand what everybody's saying, hopefully.
So how many squares are you saying?
So this is your starting point, right? And these are the 2 add.
How many total?
And then you're gonna add 2 to that one.
Think about it. This is
Now,
4
well, look at the numbers.
across
How
the
many
bottom
total
of
blocks?
that. And you're telling me I need 55 squares?
How many total blocks?
And you got the problem.
Totally told that. Like, I just noticed that. Well, I noticed it right now, but
What's
like,
great?
my
Because I like you connected easy.
does that, but I realized it was
But we notice that we have 1 across the bottom here at stage 1.
Just like we were showing.
2 across the bottom at stage 2. 3 across the bottom at stage 4 across the bottom. I kind of see a relationship, right?
At 2.
My bottom
3 more
top.
times,
But
right?
if I do
So
these
stage 5 would
as
have
how many
that.
is on the bottom, then what would I say about my vertical?
stage 6 would have stage 7 would have.
So talk with each other. Let go of your complicated method for a moment. We'll have to come back to that. It will be added. Yeah. We're close.
5 times 5 is the same as 5 plus 5 plus 5 plus 5 plus 5.
You have these blocks and these blocks, and this shares a location. You can't count it twice.
So
There's only one. You know what I
this
mean?
stage 4.
Getting that?
4
Yeah.
times 2 is what?
Whoa, gravity! Alright, let's bring it back together. Got some people throwing things.
There's 7. Right? So yeah, multiply by 2.
Yeah, I'm watching you. Kate, right? I'm watching you.
So that'll work.
Now I know your name because you're throwing stuff. What are we looking at? Hold on. Here, right? Yeah. Patrick? Patrick has his hand up. Patrick, what do you got for us?
So I found, or let's, what is it called? A pattern or a thing that can help you figure out how many blocks are in there,
Okay.
which is easier. So,
Yeah, come on. I never want to make you guys uncomfortable, but if you want to come up, just come in. I like when you guys are like, can I come up? But I'm never going to say no, you can't. I love when you guys take over.
Alright, just ahead of time, my handwriting's terrible. So
Okay.
I will
Mine's probably worse.
So N is the stage number, right? So I realized that you're adding 2 every time. But say you're at stage 100, and there's 100 at the bottom and 100 at the top. But since you counted the bottom, the corner right here has to be taken away. So it's basically 100 plus 99.
Patrick, will you do me a favor and stop moving the page so much? You're making me like seasick. So every time you shift that, it's shifting everything that we're looking at.
Okay. Then the stage number times 2 minus 1. So times 2, and then let's say that's a minus 1 equals.
You're killing me. You could have just written it off to the right there, but instead you had to mangle it. All right. I love what Patrick said. Let's clean up what he wrote. So Patrick said, I'm going to take my stage number and multiply it by 2 because I've got that many standing up and that many laying down. However, he realized that if I counted this as part of my laying down and I count it as part of my standing up, I have double counted it, so I must take it away. Do we all get that, what he said with that? So he then said the squares needed at stage N will be 2 times the stage number, and then take away that 1. So let's play this out. At stage 10, if I was you, I would write this down, at least the formula at the top of the post-it here. What's 2 times 10? 20. Take away that 1. 19, which would mean that I could have 10 laying across the bottom, 9 more standing up, and I'd make the L that I'm looking for. So that is absolutely correct. At stage 10, we will use 19 squares. Did anybody figure that out, but in a different way? This is correct, but it's not the only way to look at it. What if instead of, yeah.
I figured it out, but then I thought I was wrong. And so, from 7, I kept on adding, so like, S in parentheses, 4 equals 7, right? So,
Yeah.
So 5, 7 plus 2 equals 9. And so I keep on, and so it'd be S in parentheses 10 equals 19. I got that, but I thought it was wrong.
Yeah, so getting it, but going each step like this is good, but it's not very efficient, right? Because it takes a long time. So I love that we figured out how we can do this. We essentially made a T-chart here. If you think about it like this, we've essentially made our T-chart with stage number, blocks needed, or squares needed. But I saw an interesting situation on a few of your papers. I think I'm going to have to steal a new paper for this. I'm going to run through all my papers, but that's okay. My smartboard, I need to restart my computer, and it takes a long time because I'm still using a desktop computer because I use 2 different screens. So I saw a lot of people doing things like this. The bottom has as many as my stage, and this has 1 less. So at 5, I'd have 5 boxes on the bottom, and how many boxes, and of course I'm not drawing my boxes, but how many boxes standing up would there be? 4 more. So if we know that this, we've been calling N the stage number, what could we call these values? If it's not N, it's close to N. Here N was 5. How could I get to 4? Here N was 4. How do I get to 3? Here N was 3. How do I get to 2?
The number at the top is always the number at the last stage.
Okay.
Wait.
So, and the last stage is always this stage's value. It's not just n, it's n. Give it to me. N minus 1. 4 is just 1 less than 5. 3 is just 1 less than 4. 2 is just 1 less than 3. So this is just n minus 1. So another way that we could say our total amount here is the squares we'll need at stage n is n for the bottom plus what? We have the n across the bottom, and then how many up? Don't be specific. Use the variables. Yeah. So we have n across the bottom, and then how many standing extra? What did we say for right there? N minus 1. So that'll be n plus n minus 1. If you wanted to like see that visually, this section is my n minus 1, whereas this section is always going to be my n. Or you can do it the other way around. You can draw your vertical as your n, and then the extras off to the side as your n minus 1. You could visualize it differently, and it still means the same thing. Well, what's interesting here, n and n, because they're both variables, what do we call two variables? Something terms. You don't know? It's a 7th grade thing, but you might know. What do we say when two people get along? They agree with each other, friends normally. Yeah, it's easier than that, actually. These are like terms. Nobody? Okay. You must have not heard that much in 6th grade. So like terms are terms that are like each other. This is a variable. That's a number. They're not alike. They don't get along. I can't do this math. But I can add an n with another n. So this actually becomes 2 n's and then the minus 1. Isn't that the same thing that we just had over here? So we ended up in the same exact place, taking a different route to get there. So this year, one of the things you're going to hear me say is there are many right ways to get to Florida. What that means, I've driven to Florida a lot to go down to Disney. What that means is there's not one correct route. We've got one correct destination. I'm going to Disney. But I don't care how I get there. If there's construction over here, I can bypass over there. If there's a wreck over there, I can bypass. I've got a lot of ways to choose. But when I get to Disney, I know I got where I needed to be. When I get to my equation, I know I got where I needed to be. It doesn't matter how I got there. So, growth mindset, believing that you can, and having that positive attitude. So, if you will, as you put these 2 sheets away in your math section, flip open your plan book and your homework. Don't worry, it's like optional. Your homework is to explore growing squares, and really I just want you to start getting used to using your plan book. So for math, for today, fill in the box with explore growing squares. I'm not going to collect this. It is not going to be for a grade. It is just so that you do not let your brain have all weekend off. We are going to talk about this more on Monday. The back of this has some other patterns, and I'm really curious if anybody can figure out the actual staircase. Who can remind me what groups are going where right now? Who's going where? We just ended beta. Lunch, right? We all go to lunch. After lunch, what's happening? But, well, depending on who you are. So, who's going to gym after lunch? But what groups? Hudson and Goldring groups. Is that by foundation or by advisors? By foundation. Hudson and Goldring foundations will have gym after lunch. You're all going to lunch right now. Thank you guys very much. Have a wonderful weekend. Play with the growing squares. Come back with questions. I'm excited to see your learning. Well, you're looking at me like I'm too excited. You got the question. Oh, it's already been solved. I'll give it to you. What do you got for me? Okay, so jaguars, 4 leg animals, right? So 16 legs from there. Birds, snakes. It's all about the snakes. Yes. Okay. It's pretty sweet. Do you think you keep adding to it if I keep pushing you to? Okay. Ninja Bird Hunter Man, I like it.
His name is Joe, with his dad, and then died by way of the gun in Cincinnati Zoo. This is Mama Bird. He's like, you killed my dad, I'm gonna kill you. This is Mama.
This is pretty good.
Throws a spear. Hits Billy.
This is like an entire cartoon strip on one picture.
Oh, yeah. It's like the random
So
then
they threw a spear. They hit him. He bleeds. He pees himself, and this is a stream of tears, pee, and blood.
I love your narrative, but that just took it too far to go on my wall. So it's very funny. Well, when you made him pee himself, it went a little too far. I'm just gonna slowly walk away from this situation. Go show that to Mr. Kabila and tell him that he should put it on his wall. One, most of my things are math, and two, he peed himself. That's inappropriate.
And that just misses tears.
It's all, dude. It's all good. We're all going to lunch, so we're just go to lunch. All right, bud. I'll see you down there. Thank you for your beautiful artwork. Just make sure to keep it appropriate.